Okay, so we're talking about calculating the mean absolute deviation, which is a three-step process. You find the mean, then you find the distance or deviation from the mean, and then you calculate the mean of those deviations. So now that everybody has that copied, I'm going to turn the paper sideways so that we can write it in the box the correct way. Okay, step one was find the mean of the data. Well, we're still using the same data we've been using the whole time, this 5 numbers right there. So don't we already know the mean of that data? 82. How do we already know that? Right, we did it on that bottom left flap yesterday. So we already know the mean is 82. Now step 2 is we're going to find the deviations from the mean. Okay, what I mean by that is the distance from the mean to the actual data. So what is 84 minus 82? 2. What is 72 minus 82? But negative 10, right? All we're doing is calculating the distance from the mean. So you're going to each original number in the list and subtracting the mean from it. So like 84 minus 82 is 2. 72 minus 82 is negative 10. 84 minus 82 is 2. 80 minus 82 is negative 2. And then 90 minus 82 is 8. Okay, so those are the deviations from the mean. That's the distance from each data item to the mean. Okay, that's how far apart they are. Now, let me pause it for a second. Okay, anytime you do your deviations right, they will add up to 0 every time. Okay, now those are our deviations. So we've done the mean so far, which was 82, and we've done the deviation list, which was how far away each number in the list was from the mean. But what have I not dealt with in this mean absolute deviation? Well, the absolute part. What is the absolute value of a negative 7? 7. Doesn't the absolute value just turn any number from negative to positive? Or if it's already positive, it stays positive. Absolute value will always just be positive. Because absolute value is distance, and can you go a negative distance? No. Okay, anytime you go distance, it's always positive. So absolute value will always be positive. So because of that, we're going to take these negative numbers and just make them positive. Okay? If it's already positive, you keep it positive. It'll always be positive when you're doing the absolute value. So for that reason, when we look at our deviations, we just make them all positive. Okay, now step 3 is we are going to do the mean of the deviation list, which means average this list now. So what do I need to do that? How do I take the average of my deviations? Add them all together and divide by how many there are, which is 5. Okay, so when you add them all up, you get 24. And then when you divide that by 5, you get 4.8. So that is the mean absolute deviation of this data. Okay, 4.8 is the average distance from the mean. Okay, so now we're done with our foldable. So you can go ahead and close it and close up your composition book and just put it to the side. And now we're going to be working in our packet. And we're going to flip a couple of pages to page 5. Okay, page 5, number 1. The first question says, the distance from the mean to each point or each data item is called the what? Right, the deviation from the mean. Okay, remember, distance is the same word as deviation. So if you're trying to find the distance from the mean to each point, which is each number in the data, that's just the deviation from the mean. What is the mean of the distances from the mean called? What? D, the mean absolute deviation. Once you take the mean again of those deviations, that's called the mean absolute deviation. Okay, now let's try a problem by calculating the MAD of it. Okay, the data here shows the average winning race speeds in the last 12 years. So I'm not sure what race this is, but we'll just say in year 1, the average winning race speed was 132 miles per hour. In year 2, it was 141, and so on. Question 3 says, what is the mean speed in the list of average race speeds? Right, so what's this question wanting you to do? Just the mean. Okay, all they want for this question is just the mean. So you add them all up and divide by how many there are. So go ahead and do that. Okay, when you added them all up, didn't you get a sum of 1,550? That's the sum. And then when you take the sum and divide it by how many years there, or was, no, it wasn't 1,550, was it? It was? And then you divide that by 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's odd. Why would they not have said the last 10 years? Kind of weird. Okay, and you get 155. Maybe there were 2 years there wasn't a race or something, I don't know. Okay, so the mean of the race speeds is 155. The average speed of a winning race car was 155 miles per hour. Now they want us to write the deviations from the mean to complete the table. So now you're just doing the distance of each average speed from the average of all of them. So like, what's 132 minus 155? 23. And isn't it negative 23? And the reason it's negative is because isn't 132 miles per hour slower than the average speed of 155? So that's why it's negative for right now. We'll change it in a few minutes. Okay, what about this 141? How much slower is it than the average speed? Right, negative 14. It's 14 miles slower. All right, what about the 146? How much slower is it than the average? Negative 9. 9 miles per hour slower. What about the 149? Right, negative 6. 6 miles per hour slower. And then what about the 151? Right? Okay, now you take a second and try to find the other 5 speeds and what their deviation from the mean is. For these 5, 154 miles per hour is how far from the average? Right, it's 1 mile per hour slower, so negative 1. Now we're getting into some speeds that were faster, so these should all be positive because they're faster. And this is how much faster? 7, and then this one is 11, and this one is, and 21. Okay, what's your question? You're supposed, yeah, you do this minus the mean. But now, it will end up okay because to calculate MAD, aren't we about to just make them all positive anyway? So it will be okay, but it wouldn't work out if you were trying to check it. If you tried to add all these up, it wouldn't equal 0. If you have them all right, they should equal 0 when you add them all up. Okay, now, like I was saying, these are the deviations from the mean, but we need them to be absolute deviations to calculate the MAD, mean absolute deviation. So we're going to make them all positive now. And to calculate the MAD, we're now going to do the mean of these numbers, which means add up all these numbers and divide by 10. So all the numbers in blue, add them up and divide those by 10, and that will be your mean absolute deviation, your average distance from the mean. Okay, 11.4 is correct. Did anybody not get that and you need to ask the question? Okay, so now this kind of gets tricky, so pay attention. Number 6 says, how many of the racers in this group scored, it really should say, I mean, that's weird to say scored for a race. So how many of the racers in this group drove, I guess, within one mean absolute deviation of the mean? They're asking how many of the racers were between 0 and 11.4 miles per hour. Was 23 within 0 and 11.4 away from the mean? No. Was 14? No. But isn't 9, 6, 4, 1, 7, and 11, aren't all of those numbers between 0 and 11.4? Which one would be the 7th one? Yeah, but I only checked off 6 people that were between 0 and 11.4. So isn't it just 6 of the drivers were within 11.4 miles per hour of the mean? The 6 I checked off have a value that is between 0 and 11.4, right? Okay, number 7, yes? 11.4 came from adding up these 10 numbers and dividing by 10. Okay? All right, now number 7. What does 22.8 represent as it relates to the list of values? Right, 2 mean deviations. Isn't 22.8 just 11.4 doubled? Well, if 11.4 is 1 mean absolute deviation, then 22.8 would be 2 mean deviations. How many of the drivers in this group scored within 2 mean absolute deviations? Who now could we check off that's now between 0 and 22.8? Right, everybody except for this one. This one was not within 2 because it was a little above 22.8. So only 9 of the drivers were within 2 mean absolute deviations of the mean. Because only 9 of these people had a value that was between 0 and 22.8. Does that make sense? Okay, now turn to the next page. What? No, there's no homework tonight. Oh, yeah, but it'll be probably the end of next week. Okay, do y'all feel ready to try one by yourself yet? Yes? Okay, let me turn to the next page so I can give some directions. Okay, look. Question number 9 says, what is the mean? So that's the first thing you're going to do. You're going to look at this data and calculate the mean. Question 10 wants to know which of these 4 tables is the correct one. So once you fill in the deviations, you'll just match it up to one of these 4 tables. Okay? So everybody get started. Oops, I just start video. And then 2, negative 7.8. And then 0. Right. Okay, so those are your deviations. And what did I tell you is special about the deviations? What can you do to them? Well, you can, but before you've made them positive, what do we know about the deviations if you added them all up? It would be 0. Okay, if we were to add up those 10 numbers right now as they are, it would give you a 0. Now, to find the actual mean absolute deviation, you have to do the absolute value of all the numbers, which means all of them become positive. Now, before you did that, which table did it match down here? C. Okay, so now to find the mean absolute deviation, you've now changed these to absolute deviations by making them positive, and now you should have averaged those deviations. So you added up these 10 numbers and divided by 10, and what did you get? 5.24. So how many of the players in this group scored within 1 mean absolute deviation of the mean? How many of the players were at least between 0 and 5.24 points Okay, this one, and this one, because aren't all three of those numbers somewhere between 0 and 5.24? And then this one, and that's it, right? Because that one's a little bit above. It's got to be below 5.24. So only 5 of the players were within 1 mean absolute deviation of the mean. What would 2 mean deviations be? What value would 2 mean deviations be? 10.48, because wouldn't you just double that number to 10.48? And how many players would have been within 10.48? All of them, right? Because all of the numbers up here are between 0 and 10.48. That one barely made it in, but it made it. Okay,